So now let's get to the hands-on assignment. So I mentioned that Hadoop is this toolkit for doing lots of great things. So you don't actually have to worry about all the intricacies of scheduling and fault tolerance and things like that. The only thing you have to be aware of
I have a question from
is
you. So
your
like,
data, your application, and trying to actually map that to the programming model in key value pairs. So here is just the classic word count example. And here I have my map function and my reduce function. So also want to mention that when we work with word count, the keys are actually the offsets of the file. So we actually really care only about the words as my values. And the job client, as I mentioned in the previous slides, is actually what runs the job. So here is also configuration parameters that you can tweak. So um, Stephen had introduced you guys to his framework for um, an environment for actually running Hadoop. So at this point, you guys should already be good to go with um, doing programming stuff. So I'll, I'll assume that. Also, I think it's important to note that, Hadoop is written in Java, but it does enjoy flavors in Python and C++, um, with this thing called Hadoop streaming and the C++ lib API. So let's, so I'm just, so Stephen's, the difference, so Stephen has his framework is batch mode. Here, I want to show you guys an interactive way of programming. So with the interactive way, you guys can actually be comfortable with HDFS commands and actually seeing
he has a
how you
question.
start the name node and the data nodes and all that good stuff.
He has
So
a
I
question.
think I'll. So in this part, so here I'm just setting up the virtual machine, right? So here I log in as root and the password as school 2012. And all of this, of course, is uploaded to the site. So now, I prepared this word count tarball to ease you in the source code and the input file, which is just a document. And also, I have this build script. This build script, what it does essentially, it compiles your Java program and it copies the jar file to the Hadoop bin so that you don't have to worry about your class path and all that stuff. So here I'm just extracting the word count. So now I kind of jumped ahead of myself, but I'm compiling it now using the build script. So now that I've compiled that, I'm going to the bin of the Hadoop. So now I'm actually want to format the HDF or the name node. So also I mentioned that when you format the name node, you only need to do that once. So now that that's formatted, I'll just start my HDFS daemons and my MapReduce daemons.
So oh, sorry.
Oh, that's fine.
So the format on the name node, what does that do?
So essentially, it just wipes the HDFS and it just formats it. That's all it does. So when you start the HDFS daemons and the MapReduce daemons, it's a good way to check to see if they're running. So here I have the name node, the secondary name node, the data node, and the task tracker and the job tracker all started. So now I'm wanting to create a directory in HDFS. So I created a folder on the distributed file system. So now I'm actually wanting to copy the data in the Hadoop word count input, copy that onto the HDFS. So now I'm actually going to execute the Hadoop, the word count example. So here the arguments are Hadoop, the jar, the jar of the word count, the class, and the input and the output. One of the things about the output, you don't need to create an output folder on the HDFS. It's automatically created. So here it's showing that it's done the map phase, and now it's doing the reduce operation.